Hey, welcome to this episode of The World Around Us. In this episode, we're going to do another stoichiometry problem. This one we're going to deal with, instead of grams and grams, we're going to be doing with the volume of gas. We're going to be dealing with liters and grams and all that other stuff. So let's get started. Let's take a look at the problem. Here's the problem. Corlander Knagelbuck was turning 29 and decided to throw herself a birthday party. She wanted lots and lots of balloons, but it's whatever. There's a lot of, here's your first, this is a free lesson inside the lesson on stoichiometry. There's a lot of information there you don't need. In fact, you don't need most of that information. What you need is find the question mark and work backwards and see what you actually are trying to do. So if I go to the end of the paragraph, there's a question mark there that says, how many grams of NaCO3 does she need to start with in order to produce 2.24 liters of CO2? So we need 2.24 liters of CO2. All right, that's not that hard. So we're going to have some grams at some point. It's going to decompose. We're going to get 2.24 liters of CO2. Scratch work. Whenever we're doing stoichiometry, we need to begin with the balanced equation. The balanced equation, and since there is a mention of grams in the problem, since grams are mentioned, you also need the molecular masses, the molar masses. And there you have the balanced equation. 2 NaCO3s decomposes into Na2CO3 plus CO2 plus H2O. In blue, underneath them are the molecular masses. So there's our scratch work, all nice and tidy for us to begin with. Now the question says that we are to find out how much of this we need in order to produce some of this. How much of this are we going to produce? So I'm gonna take my purple Sharpie. Purple has no meaning. It's just the one in my hand went on. I'm gonna draw a line. No, that's my scratch work up there. Molecular masses and balanced equation. And I'm gonna write underneath here the question mark. That means this is what I'm looking for. Question mark is I need 2.24 liters. 2.24 liters. That's an L. It's an L, not a 1. 2.24 liters. That's what I need. There's no liters in my balanced chemical equation. There's no liters in the equation. There's no liters up there at all. I got to go somehow from liters to grams. And the only way I know to do that is to go through moles, to go through the moles that are involved in this ratio of molecular masses, this ratio of molecular parts. The molar ratio, the coefficients tell us 2 moles of this, 1 mole of this, 1 mole of this, 1 mole of this. That's what we've got. How do I get from liters to moles? Well, that's super easy. Because we know, or we can look it up, or we can find out that 22.4 liters of a gas at STP is 1 mole. So if I have 22.4 liters is a mole, and I want to know how many moles I have, I can take to get, let's just do that. The volume is equal to 22.4 times the number of moles. So if I want the number of moles, I'm going to take the volume and divide by 22.4. So V divided by 22.4 equals N. Now I have 2.24 given, and there's a number, and there's a number, and there's a division, and I can probably do that. So I'm going to take the 2.24 liters that I was given in the story, 2.24, and I'm going to divide it by the definition, this definitional 22.4 to get N. The number of moles of gas that I need to produce, is going to be this number divided by this number. Get my calculator out, and I get 0.1. This is a very important number because this is our first number of moles that we've calculated. So we're going to put that in a box so we don't lose it on the page. So now we know the number of moles that we need to produce, because 0.1 moles is 2.24 liters. 0.1 mole is 2.24 liters. So now the question becomes, if I have 0.1 moles of this, how many moles of this do I need? And then once I know how many moles of this I need, I can go from moles to grams. So I'm going to skip down to the moles to grams thing, because what I need to know is how many moles of this are there. So the question was grams. So how many grams do you need? Grams equals moles in times molar mass. So the question was, how many grams of this stuff do I need in order to create this much of this thing? How many grams of this to create 2.24 liters, which is 0.1 mole? Grams is in times the molar mass. Molar mass I have, 84. Something times 84.0. Something. I don't know what the something is yet. But once I know what that something is, once I know how many moles of this, I can just plug it in there, multiply, and be done. In order to do that, I've got to go from the theoretical recipe to the ratio there to a working recipe, a working ratio. What are we actually working with? So in order to get the recipe ratio, I take the coefficients. 2 moles of this will result in 1 mole of that, and 1 mole of that, and 1 mole of that. Now where did I get the coefficients from? That comes down. We do not write ones in chemistry grammar, but if we did, there would be ones in here, and that would come down. And if we did write the ones, there would be a 1 in here, and that comes down. And if we wrote the ones, there would be a 1 here, so that comes down. So that's where we got the 2, 1, 1, 1. That is our recipe ratio. If I have 2 moles of this, I will produce 1 mole of this, 1 mole of this, and 1 mole of this. But I don't need 1 mole. I don't need a whole mole. I only need 1/10 of a mole. Logically, if I need 1/10 of a mole of this, then I need 2/10 of a mole of that. If I need 5 moles of this, then I need twice as much of that. If I need 20 moles of this, I need 20 times as much as that. All right, so what I have is a way of coming up with my working ratio is to divide what you have by what was expected. And since we're dealing with the CO2, I'm going to put this in purple. So I'm going to take this divided by this, and that's going to give me a number. And then I'm going to multiply the whole ratio by that number. Now, it's not hard because the 1 is the coefficient. And a lot of times the coefficient is 1 or 2 or 3, occasionally a different number. So I'm going to take 0.1 divided by 1, and then I'm going to multiply the whole recipe by that. I'm just going to write that here. REC, period, because whatever. I need a working ratio, so I'm going to write that down here. I'm going to call it working ratio. This is the ratio that I'm working with in this problem, in this story. So I'm going to create a number that I can use to multiply that whole ratio by? I'm gonna call it my multiplier. So it's going to be the number that you actually have divided by recipe. How much you have divided by the recipe equals a multiplier. 0.1 divided by 1. Now where did this come from? So the 0.1 came from here, and the 1 came from there. 0.1 divided by 1, anything divided by itself is itself. 0.1 divided by 1, 0.1 equals the multiplier. Now I'm going to take my multiplier, I'm going to multiply the entire recipe ratio by that multiplier times 0.1. And that's going to give me a working ratio. It's going to give me a ratio that I'm going to actually work with. And I'm just going back to black because it's not that hard. 2 times 0.1 is 0.2. 1 times 0.1 is 0.1. 1 times 0.1 is 0.1. And 1 times 0.1 is 0.1. So my working ratio tells me that I need 0.2 moles of that. I need 0.1 moles of this and 0.1 moles of that and 0.1 moles of that. I have 0.1 moles of this. That's where I got the 0.1 from. I got that. That's where it came from. So I'm going to take this number, 0.2. I'm going to shove it into the N for grams, 0.2. I'll just use this one. Point 2 times 84. So it's going to be 168. Move the decimal place, 16.8. And at this point, if I had students in the room, I'd say, someone check that. So I'm going to check that because I have notes on the screen. 16.8 grams. 16.8 grams of this will produce 2.24 liters of that. Now we could use the same logic for all of the other parts. We could do the 0.1 times the molecular mass of CO2, so we would have 4.4 grams of CO2, 1.8 grams of this, and 10.6 grams of that. So we can take this working ratio, apply it to all the molar masses, and find out what the masses of all the parts are. But our question was, how many grams of this do we need to start with in order to produce this many liters of this, 2.24 liters. Really quick recap. First of all, make sure you know what the question is. Don't get lost in the minutia of all the balloons and stuff. 2.24 liters of this, that's what we're looking for. Converting this into moles, 2.24 liters converted into moles. So I divide by 22.4, gives me a number of moles. This is how many moles I'm actually working with. This is my working number of moles. I take the recipe ratio, and then I find the corresponding coefficient to whatever it is I'm working with, divide what I have by what I was expecting. What do you have divided by the recipe gives you a multiplier. Multiply the whole ratio by that. That gives you your working ratio. That gives you your working ratio of moles. 0.2 moles, 0.1 mole, 0.1 mole, 0.1 mole. Now I can go to liters, I can go to molarity, I can go to whatever, because now I have the moles to work with. There's a lot of steps. And by the time you get done, and especially when you're highlighting and drawing lines all over the place, it looks ridiculous. But typed out, and just looking at it typed out, it's not so bad. As I've been typing it out on the screen as you go, it's not so bad. So using this kind of as a roadmap and using the typed out version as kind of a more sensible look at it, it's not that bad. There is a lot of steps, and I feel like one of the challenges of doing this stoichiometry is forcing yourself through all the steps, because any single piece of this is basically just dividing or multiplying, or sometimes multiplying and then dividing. So we take volume divided by and we get a number, and then we take a number and divide it by a number and we get a number, and then we multiply some numbers and we get some numbers. If you can balance the equation to start with, if you can find the molecular masses to start with, if you can do the scratch work, the stuff above this line here, you are almost done, except for just a few little steps here. So it's like balance equation, 1 step, molecular masses, 2 steps. What are you working with? Finding that what you actually have. Apply what you actually have to the recipe to get a working ratio. And once you have that working ratio, it's just like, oh, I'm gonna go to grams. I'm gonna take this one and go to liters. I'm gonna make a solution and go to molar. Whatever you want to do with the other ones. That's it. I'm gonna stop talking now. These videos are challenging to make, to think through all the steps, and I'm sure they're challenging to watch. So let's call this one an end. Let's bring this one to a close. Thank you for watching. Please click. Don't lick any buttons. Don't lick any buttons. Just click it. Click the like button. I can't believe I said that. Click the like button. Subscribe to the channel. Sign up for notifications. Leave me a comment, question, or a suggestion. I haven't tried to do a pin flip in a while. Let's see what happens. Got it. No look. I was kind of looking at the camera. See you in the next one.